one of the greatest areas of research in emotions is on emotional phase expressions, and Paul Ekman was one of the first to actually suggest that there are these basic 6 emotions. Now today it's called 7 emotions, and if you dig deeper into it, you will see that there is a lot of differentiation between what types of emotions are categorized into certain categories. So it's a really messy field to say something very exact about what type of emotion is which. But based on these facial expressions, a lot of studies has been carried out. So you have these basic 6 expressions that are believed to be coded in the facial expression of these subjects here that you can see here. So the fear and the anger and the disgust and surprise and happiness and sadness, and maybe you can try and pair the facial expressions with the different emotions. Sometimes it can be a bit difficult, especially when you're presented with these faces in experimental settings. And what they usually do is that you remove hair and everything, so it's just faces that look like this, and then you have to judge the expression based on these. This has actually also led to some quite interesting studies, because it seems that the amygdala is actually able to code the emotional state of even unconsciously presented stimuli. So if you present an image very rapidly, so in this case I think it's a fearful face, and then you afterwards have a neutral face, what you say is that this first emotional phase is masked by this second phase here. I will talk a bit more about masking as a way to study consciousness next time. But the idea is that if you first present one image and then something else just briefly after, you will consciously only see the second image. But, and this is then a neutral image that's presented here, but if it's presented brief enough, this emotional image, then you're not consciously aware of it. So you cannot really report that you see it. But still, what they found was that in a study here where they paired different emotions, you could actually see that the amygdala, depending on what type of emotion that you presented. So in the first case, you have a masked image here where you see increased in the left, oh, that must be the right one, right amygdala, and then in the other case you have these non-masked images that you see, then you present it in the other. So even when you have masked these images, they are in some ways the emotional state is represented in the amygdala. And it seems that the amygdala actually has some back projections to even early visual areas, but also receives information from later visual areas. So it's again involved in these networks together with sensory areas, but also in connection with prefrontal areas. And those seem then to be able to code these emotions together. However, even though that the amygdala seems to be able to code the emotional state of, for instance, a fearful image or a happy image, then it's also been shown that through attention, so the idea of putting attention to a certain type of stimulus, for instance, somewhere in the visual field, can actually also modulate the way that the amygdala responds to stimuli. So it's not, I mean, it's not like a complete open gateway of having emotional stimuli coming directly to the amygdala without any sort of modulation from other processes. For instance, attention can modulate the way that the amygdala functions and thereby adjust how much response you will have to these emotional phases. So it's not like a complete distinction saying that, okay, it just processes the unconscious stimuli that then can become consciously available, and also the consciously available stimuli. There's also been other studies where you, for instance, pair or you look at how you see, in this case, faces and houses, and you have different states where you either see the face of the house, so you make these binocular stimuli, which I will also tell you a bit about next time. But the idea is that you present one image for one eye and another image for the other eye, and by doing that, you will have a changing percepts between what you see on either one eye or the other eye, so it's not a mixture. And you can then see that these facial expressions, they are then again coded in the amygdala, depending on whether they're neutral or fearful. But you can see also that you get the happy ones as well, so it's not just the fearful ones that are coded in the amygdala, it's also the happy faces that will be coded in the amygdala. Another quite important thing, and that also leads back to some of the studies by Darwin, is the idea that you can actually put in also body expressions that can then match your facial expression. So in this study, they actually looked at cases where you coded, so it's a bit difficult to see, but you have an angry face and you have a fearful face, and you then put a body that's expressing anger or fear on top of that. And then sometimes you make a mixture, so you put an angry face on a fearful body and opposites. And then you can actually see, if you look at, this is EEG recordings, so they look at the responses to these EEGs, to these images, and you can actually see that there are higher responses when the emotional body language matches the facial language compared to when you mix them up. So the emotional expression becomes stronger when you have included also the body representation as well. And there are a lot of suggestions on how this body language is incorporated into the way that the amygdala works and processes the emotions, and how the awareness of your body states then become. So there are some of the circuitries here between the amygdala and the superior colliculus and the pulvinar of the thalamus and the striatum, which seems to be reacting to emotional body language in a more reflex-like way. Some of these responses can then code to areas that are responsible for making a more conscious body awareness schemes of body awareness processes, so that you actually become consciously aware of this body language. And then finally, that can also then lead to emotional responses in the way that you express your body language. So it seems that even the way that bodies are expressing emotions are also coded in a network that is not only the amygdala, but it also includes a lot of the other regions that are responsible for body perception. Some of the molecular mechanisms that are involved in these, in this case, the fear conditioning, as I've taken as an example, is basically that you have an LTP-like process going on in the amygdala when you condition the unharmful stimulus with a harmful stimulus. So you have an elevation of postsynaptic calcium, and then you can enter that, and that could go through different either NMDA receptors or voltage-gated calcium channels, and then you have elevation of the calcium intracellularly. There's been some studies where you actually disrupted these voltage-gated calcium channels and in rats, and you could actually see that if you did that in the lateral or the basal nucleus, you could actually disrupt this fear conditioning process. So it seems to be LTP-like mechanisms that goes on in the amygdala. And that was it.